the failure mode and effect analysis, and the cost priority number method. Their application depends on the maturity level and the data availability. Choosing the best method for individual risk analysis is a key question. In the second step, we investigated the most important risks by collecting real case studies and creating a technical risk database with the information obtained. We created a collection of PV failure data sheets for all components and for different project phases. PV failures are assessed according to 5 different performance categories and 3 safety categories that had been previously defined. We continued to collect statistical risk data, which requires detailed measured failure input data that allows us to generate statistical data on PV system degradation rates and power losses based on failure types in different climate zones. The chart in the middle shows the failure frequency of PV module defects affecting the system performance with slow degradation over time and sudden events. In the third step, we use three real case studies to calculate the economic impact of soiling and PID, as an example, over the project lifetime of a PV plant using the revised CPN method. This method not only allows us to estimate the economic impact of certain failures on the LCOE, but also to evaluate the effectiveness of the mitigation measures. The calculations have shown that it is possible to determine the best economic solution for a given PV system, a given failure scenario, and a given mitigation approach. An example, cleaning routines and frequency in case of PV power plant soiling. The CPN method applied shows that in practice it is important to understand how risk mitigation measures can be considered as a whole in order to calculate their impact and thus evaluate their effectiveness. To conclude, solar bankability must be data-driven. Big data is available, but it needs to be better organized and digitized, relying on interconnected digital platforms. Digitalization is a driving force that can be used ultimately to ensure a cost-effective increase in the quality and reliability of PV components, systems, and projects. Data-driven evaluation of techno-economic performance indicators is a key to taking total cost of ownership decisions support to the next level. The European Technology Innovation Platform for PV, ETIP-PV, has developed a strategic research and innovation agenda for photovoltaic science, technology, and engineering in Europe. The agenda analyzes 5 interrelated PV research and innovation challenges. The second challenge is to improve the lifetime reliability and sustainability of PV systems through advanced technology and manufacturing and applications. Further insights will be provided by ETIP-PV Chair Marko Topic in his plenary presentation on Wednesday. Thanks are due to the German Federal Ministry of Economic Affairs and Energy for its continuous support on numerous projects. Thanks are also due to the European Commission for its support, especially for projects under the Horizon 2020 program. I would like to thank my current and former employers for their support in carrying out research projects and client projects in the field of PV quality. I'm deeply indebted to all colleagues who have shared their experience with me and worked together to achieve our goals. My sincere thanks also go to the ITPV committee, whose members are excellent source of scientific and technical expertise and competence. My special thanks go to the great PVPS network, all the task experts and the chair and their secretary Mary, the executive committee members I have the pleasure to work and sometimes travel with, who not only share the spirit and passion for the quest for a future global sustainable energy system, but also have many stimulating conversations